All right, so let's start stoichiometry. And I know it's a big, scary word, and I know I'm not here to teach it to you, but we're going to go for it, okay? First thing I want you to notice about your page numbers about your notes, is that for your left side activities, to help you guys out, I've actually put the answers in the margins. So when you work a problem, you'll know if you got it right. Now, when we check the notebooks, you have to have it worked because I already have the answers. So make sure you're working those left side activities, and if you need to watch the video over and over, then you watch the video over and over. So this first part we're going to do is just an overview, and we're just going to understand the mole ratio, because every problem is going to require a mole ratio, and every problem is also going to require a balanced equation. So let's get started with the notes. So stoichiometry is a proportional relationship between two or more substances in a chemical reaction. Okay, so this relationship can exist between moles, grams, volume, which is going to be usually measured in liters or milliliters, or it can be between atoms. We are mostly going to be doing the first three. Okay. Basically, what stoichiometry is it is a way that I can compare what I have in an equation. In other words, if I go into the lab and I weigh out 100 grams of my reactant and I do the reaction, I can calculate how much product I should make. Okay, so that's what we're going to be doing. But it's also where we've been talking about, I've told you all year long, we're learning the pieces of the puzzle, we're learning the pieces of the puzzle. Well, this is where we're putting the pieces of the puzzle together. And so if you've understood the pieces of the puzzle, you're going to be pretty well off, and you'll be, hey, this isn't so bad. If you are still struggling with the pieces of the puzzle, like how to do molar mass, how to go grams to moles, how to balance the equation, you're going to probably struggle with this unit, and you're going to need to go back and get some of that information from previous units. Okay, so stoichiometry is the study of the amount of substances consumed, and you must always write this big and bold. You must always, always, always start with the balanced equation. We're actually going to write that about 3 or 4 times because it's so important. You cannot do stoichiometry problem and get the correct answer if you do not balance the equation. So what the mole ratio is, it is the basis for all problems. Again, it will always come from the balanced equation. Okay, the balanced equation gives you the mole relationship between the substances. So the coefficients, those big numbers we balance with, the coefficients are equal to the number of moles in a problem. Okay, so let's look at this example of the formation of ammonia. Okay, when I look at this, this means there's 1 mole of nitrogen, there are 3 moles of hydrogen, and together when they react, they will form 2 moles of ammonia. Okay, so this first example says how many moles of NH3 are produced from 3 moles of hydrogen. So we go look at the balanced equation. For every 3, we get 2 moles. So for every 3, we get 2. So this would be 2 moles of ammonia. Okay, how many moles of hydrogen react with 1 mole of nitrogen? Again, 1 mole of nitrogen requires 3 moles of hydrogen. Okay, and this down here is just kind of a general equation to show you that this would be 3 moles of A, 2 moles of B, 2 moles of C, and 1 mole of D. Okay, don't worry about this. We're not going to really use that. Okay, I just wanted you to see that general equation. Okay, so let's work a couple of examples so I can make sure you understand the mole ratio. Okay, this is that same problem from the previous slide. You still have it on your page. I'm going to go ahead and write it at the top so that when I refer back to it, you can see it on this slide, but it is still on your page. So it was N2, so 1 mole of nitrogen plus 3 moles of hydrogen are going to yield or form 2 moles of ammonia. Okay? So I know you could do this in your head for this first little step. So it's kind of like when we started dimensional analysis. We're going to have some longer step problems, so please set it up in the grid like we've been doing because we're going to have more than one step. Today, just mole ratio is just one step, but more steps are coming. Okay, so let's always start with what we are given in the problem. Okay, We are given 2.5 moles of nitrogen, and it wants to know how many moles of ammonia can we form. So we do 2.5 moles of nitrogen. Oops, it's N2. Do our grid, and this is what our mole ratio is, okay? We are going to know that we want to get rid of moles of nitrogen, so I'm going to put in moles of nitrogen on the bottom, okay? Your mole ratio is the way that you get from what you are given to what you're trying to get to. This is our conversion. So anytime we're going to have moles of given, we're going to put it on the bottom. We're given moles of nitrogen, we're going to moles of we need to get rid of it. We are trying to get to moles of NH3. So we write moles of NH3. Okay? Now we go to our balanced equation to get the numbers that are the conversion factor. So for moles of nitrogen, I have nothing in front of nitrogen, so it's a 1. For moles of ammonia, I have a 2, so that 2 now goes here. Okay? And just like the other rules, we multiply the top, divide by the bottom, and so we would see that our answer would need to be 5, and it needs to be 5.0 moles of NH3. And the reason it has to be that is because this right here has 2 significant figures. And we match our answer to what's given to us in the problem. Okay, let's try another one. This one is 6.0 moles of hydrogen is our given, and we're wanting to know again how many moles of NH3. So I start with the given, 6.00 moles of hydrogen. I want to get rid of hydrogen, so I put it on the bottom, and I'm trying to go to moles of NH3, so I put it on the top. Now I go to the balanced equation. In front of hydrogen I have 3. So for every 3 moles of hydrogen I can get, and I've got that 2 moles of NH3. Okay? And then whenever I do that math, I multiply the top, divide by the bottom, and I should get 4.00 moles of NH3. And I've boxed my answer. I forgot to box the other one. Okay. Again, this has 3 significant figures right here because of the decimal, so we need our answer in 3 significant figures. And remember, I can't tell you how important it is, always start with a balanced equation. Okay, when you're going through this unit, sometimes you will have the equation already balanced and sometimes you will not. Here's the thing, just like always show your work. If you don't show your work, you don't get credit for it. Okay, so here's a couple of practice ones that I'll do with you. Same equation, still working with that ammonia equation, which is N2,3H2. This time we have 0.6 moles. Okay, so we're going to start with that, and we're looking for moles of ammonia. Boy, aren't we just tired of this equation by now. 0.600 moles of nitrogen. Okay, we're going to need 3 significant figures in our answer, so let's keep that in mind. Again, we're getting rid of moles of nitrogen. We're trying to go to moles of ammonia, so that goes on the top. We go to our balanced equation. Moles of nitrogen is nothing in front, so it's a 1. NH3 is 2. And then we do that math. And we multiply and divide by the bottom. And in 3 significant figures, we would get 1.20 moles of ammonia. And that would be my answer. Okay. And then the last example is the formation of aluminum oxide from its elements. We're given 2.3 moles of aluminum oxide, and we want to know how many moles of aluminum are needed. So first thing we always check, is the equation balanced? And it is not. Okay, I've got 2 oxygen and 3. So I'm going to do 3 here to get 6. I'm going to do a 2 there to get 6. And now I have a total of 4 moles of aluminum. And now I can start my problem. So again, always start with what number they gave you in the problem, 2.30 moles of aluminum oxide. Okay. We're going to need 3 significant figures in our answer, so let's keep that in mind. I want to get rid of moles of aluminum oxide, and I'm trying to go to moles of aluminum. So now I go to my balanced equation and get what those numbers are supposed to be. So in front of aluminum oxide, I have a 2, so I put a 2 here. In front of aluminum, I have a 4, so I put a 4 here. All right, and now I multiply the top, divide by the bottom. So I do 2.30 times 4, make sure you hit equal, and then divide by 2. When you're putting this in the calculator, you have a couple of choices, and whichever way you like is your choice, your personal preference. You can multiply the top, hit enter, divide by the bottom. You remember, as we get more complicated, we have on our calculators that N over D key that we talked about in the beginning of the year, where you can just hit that key and then punch everything on the top, then go to the bottom, punch in everything, and then equal, and you should get the correct answer. Okay, so when we do that, we get 4.60 moles of aluminum, and that is our answer. Okay, so you do have a worksheet that's a mole to mole, and then you also have your left side activities. I kind of suggest starting with your left side activities because I have the answers written there for you, so you can kind of check yourself. All right, and next time we'll pick up with the real stoichiometry, which is beyond the mole ratio.